Hello and welcome to another video. Today's video will be solving this pretty simple problem from last year's AIME number 1. This is question number 5. If you want to, you can go ahead and pause the video and try to find the solution. I'll go ahead and solve the problem now. Now, of course, there's many ways to go about this one problem, but in today's video, I'm going to focus on using the power of a point properties. So let's just get started. So yeah, the problem tells us that we have these two rectangles, and then the more important part is this part. So ADHG all lie in a circle. I'll go ahead and make my best attempt to kind of draw that circle. Ooh. Okay, it really doesn't have to be a perfect drawing, and you don't really need to draw the entire circle either. Just this should be enough to provide a visual. And then we'll just write in the values that were given. So BC is 16, AB 107, FG is 17, EF is 184. And we're trying to find CE, which is like this. It's not the whole side length of either rectangle. Now, if we're trying to find CE and we know the value of the EF segment, perhaps we would either need to find this or this, since we also know the AB segment length. Now, it may not be entirely clear where we can use power of a point, but I'll go ahead and draw a point outside of this circle to help us with that. We'll call this point X, which is kind of just filling in that rectangle there. And now it might be more clear on how we can use power of a point. I'll also set the value DE to just be a variable A. Okay, so I'm just going to apply power of a point directly now. Power of a point tells us that XD and my drawing is a little bit off, as you can see here. This should be intersecting there, so I'll fix that. XD times XA equals XH times XG. And we do know some of these values because they're given. So XD is 17. XA is just 17 plus 16, so. And then that's equal to XH times XG. XH earlier we set to be A, or we set DE to be A, but DE is equal to XH. So A times, and then XG would just be A plus 184. And as you can see, this just turns into a quadratic. So the quadratic turns out to be, if you expand it and move everything to one side, and this does factor pretty nicely. And of course, you can't really have negative of the length of a segment, so this would just not be the right route that we want to use. So we'll use this one, that DE or A equals to 3. So now the problem is quite simple. If we have the entire AB and we know that value, to get CE, we're just going to subtract whatever DE is. So our answer would be 107 minus 3. So it would be 104. Thank you so much for watching. Please like, share, and subscribe.